Good day everyone, I am Kyla Generato and I will be going to discuss the Chapter 23, Lubricant System Operation and Diagnosis. And for the learning objectives, at the end of Chapter 23, students will be able to first is describe the key components and functionality of lubricant systems. Second is identify and diagnose lubricant system issues. Third one is apply best practices for lubricant system maintenance and repair. Lubrication principles. Lubrication between two moving surfaces results from an oil film that separates the surfaces and supports the load. Makikita natin sa picture, ang lubrication between two moving surfaces happens because of an oil film that separates them and supports the load. Yung oil film na ito ang nagsisilbing cushion para hindi magdikit ang dalawang surfaces, kahit nababawasan ang friction. Ang oil film din ang tumutulong para masupport yung load o bigat na kinikilos ng mga moving parts. Kaya't napipigilan ang mabilis na pagkasira ng mga ito at tumatagal ang buhay ng makina. Boundary lubrication. Although oil does not compress, it does leak out around the oil clearance between the shaft and the bearing. In some cases, the oil film is thick enough to keep the surfaces from seizing, but can allow some contact to occur. Boundary lubrication happens when the oil film between the shaft and the bearing is thin enough that it can completely prevent contact between the surfaces. Kahit na hindi nadideform o compress ang langis, minsan umaagos ito sa oil clearance or sa mga espasyo sa pagitan ng shaft at bearing. Sa ilang pagkakataon, yung oil film ay sapat pa rin para maiwasan na magsanib ang mga surfaces. Pero may mga pagkakataon na may konting contact pa rin na nangyayari. Kung hindi maayos yung boundary lubrication, pwedeng magdulot ito ng friction na magre-resulta ng pag-init o pagkasira ng makina. Hydrodynamic lubrication. This waging action is called hydrodynamic lubrication and depends on the force applied to the rate of speed between the objects and the thickness of the oil. Ang hydrodynamic lubrication is parang yung oil nagpo-form ng wedge shape dahil sa pag-ikot. This wedge shape na oil film is nagka-create ng pressure. Kaya yung journal is parang nagpo-float sa ibabaw ng oil. No direct contact, so less friction. It depends sa force, speed, and thickness ng oil. Engine lubrication systems. The primary function of the engine lubrication system is to maintain a positive and continuous oil supply to the bearings. Engine oil pressure must be high enough to get the oil to the bearings with enough force to cause the oil flow that is required for proper cooling. Ang engine lubrication system ang nagpo-provide ng tuloy-tuloy na supply ng oil sa mga bearings para maiwasan ang friction and wear. Kailangan mataas ang oil pressure para ma-deliver ang oil sa lahat ng mga parts, ensuring proper lubrication at cooling. Basically, it's like the engine's bloodline, keeping everything running smoothly and preventing overheating. Normal oil pressure. The normal engine oil pressure range is from 10 to 60 psi or 200 to 400 kPa or 10 psi for 1000 engine RPM. It is normal to see the following. Higher oil pressure when the engine is cold due to the oil being cold and at a higher viscosity. Lower oil pressure when the engine is at normal operating temperature due to the oil becoming thinner even though it is multi-viscosity oil. Lower oil pressure at idle and high pressure at higher engine speeds because oil pumps are positive displacement pumps. Ang normal oil pressure is usually between 2 between 10 to 60 psi or pounds per square inch or 10 psi per 1000 rpm or revolution per minute. Expect higher pressure when the engine is cold kasi mas makapal ang oil, and lower pressure when hot kasi mas manipis na ang oil. Even with multi-viscosity oil. Also, low pressure or at idle and high pressure at high RPM are normal kasi ang oil pumps are positive displacement, meaning they pump more oil as the engine speeds up. Oil temperatures. Excessive temperatures, either too low or too high, are harmful to any engine. Estimated oil temperature can be determined with the following formula. Outside earth temperature plus 120 degree F equals estimated oil temperature. For example, 90 degree F outside air temperature plus 120 degree F equals to 210 degree F estimated oil temperature. Ang oil temperatures are crucial. Too hot or too cold is bad for the engine. You can estimate the oil temp by adding 120 degree F to the outside earth temp. For instance, if it's 90 degree F outside, the estimated oil temp would be 210 degree F. This formula helps give you a rough idea since extreme temps can damage the engine's lubrication. Oil pumps. All production automobile engines have a full pressure oil system. The oil pump is required to provide 3 to 6 gallons per minute of engine oil to lubricate the engine. Maintain pressure by forcing the oil into the lubrication system under pressure. Ang oil pump sa mga kotse ay crucial para sa full pressure oil system. They need to pump around to 3 to 6 gallons per minute ng engine oil para malubricate ang engine. More importantly, kailangan din itong i-maintain ang pressure para ma-force ang oil sa buong lubrication system, ensuring na lahat ng parts ay nakakakuha ng tamang lubrication. Parts and operation. In most engines that use a distributor, the distributor drive gear meshes with the gear on the camshaft. Sa karamihan ng mga makina na gumagamit ng distributor, makikita sa picture yung distributor drive gear ay nakakabit sa gear na nasa camshaft. This connection is crucial kasi yung pag-ikot ng camshaft ang nagpapaikot din sa mga distributor shaft. At the same time, nagpapa-under din ito sa oil pump. So, yung rotation ng camshaft ang nagko-coordinate ng ignition timing at lubrication. Types of oil pumps. All oil pumps are called positive displacement pumps, and each rotation of the pump delivers the same volume of oil. Therefore, everything that enters must exit. Lahat ng oil pumps ay tinatawag na positive displacement pumps, meaning kada ikot nila pareho lang ang dami ng oil na dinideliver. So, kung ano ang pumasok, yun din ang lalabas. This ensure a consistent and reliable flow of oil for engine lubrication. Most automotive engines use one of two types of oil pumps, either gear or rotor. Sa gear type, merong external gear type and internal gear type. Ang external gear type, ito yung tinatawag na external gear type ng oil pump. Kumbaga, dalawang gear ang nasa loob ng masikip na housing, yung isa pinapaikot ng shaft mula sa distributor, tapos yung isa sumasabay lang. Dahil dito umiikot ito sa kalahati na bilis ng makina. Habang umiikot yung mga gear, nagkakaroon ng space sa mga pagitan na mga ngipin nila. Doon pumapasok yung langis mula sa inlet. Tapos yung langis dadalhin sa labas ng gear papunta sa outlet. Pagdating sa gitna, pipigayin yung langis palabas kaya nagkakaroon ng pressure. Sa internal gear type naman, ito yung tinatawag na internal gear type ng oil pump. Iba ito sa external gear type kasi yung gear na nasa loob mismo ang umiikot, hindi yung nasa labas. Directly connected ito sa crankshaft. Kaya umiikot ito sa parehong bilis ng makina. Ang ginagamit dito ay dalawang gear. Isang internal gear yung malaki na may ngipin sa loob at isang external gear yung maliit na nasa gitna. Meron din itong crescent stationary element, yung parang kalahating buwan na bakal na nakikita sa picture. Ang trabaho nito ay para i-separate ang pressure side at suction side ng pump. Habang umiikot ang gears, nagkakaroon ng space sa pagitan nila at ng crescent. Doon pumapasok ang langis. Tapos, habang nagme-mesh ang gears, pinipiga ang langis palabas kaya nagkakaroon ng pressure. Basically, mas kompakto compared sa external gear type at mas efficient sa pump ng langis. Sa rotor type naman, ito naman yung tinatawag na rotor type na oil pump. Ito ay pinaiikot din ng crankshaft. Kaya ang bilis nito ay depende sa bilis ng makina. Ang pinaka-unique dito ay yung mga rotor na ginagamit. Meron tayong inner rotor, yung nasa gitna, na may special na lobe shape, at outer rotor, yung nasa labas, na mas malaki at may lobes din sa loob. Yung inner rotor ang pinaiikot at yung outer rotor naman sumasabay lang. Sa picture makikita natin yung proseso. Sa letter A, habang naghihiwalay yung mga lobes ng inner at outer rotors, nagkakaroon ng space. Dito pumapasok yung langis mula sa inlet, parang sa gear type pumps. Habang umiikot yung mga rotor, dinadala nila yung langis sa pagitan ng mga lobes. And sa C naman, pagdating sa outlet, nagme-mesh yung mga lobes. Pinipiga nila yung langis palabas, kaya nagkakaroon ng pressure. Same concept din sa gear type pumps. Ang goal ng pump na ito ay mag-maintain lang at least to 10 psi na pressure sa oil gallery kapag mainit na yung makina at naka-idle. Pag mas mabilis ang takbo ng makina, mas mabilis din ang ikot ng pump. Kaya mas mataas ang pressure. Kaya importante ang oil pump para malubricate na maayos ang makina. Ang second naman is Generato type. Ito yung isang uri ng positive displacement pump na gumagamit ng inner at outer rotor. Galing ang pangalan nito sa generated rotor. Ang inner rotor ay mas may kaunting ngipin kaysa sa outer rotor at pareho silang umiikot. Habang umiikot sila, nagkakaroon ng space na pinupuno ng langis. Tapos habang nagme-mesh yung mga ngipin, pinipiga yung langis palabas. Kaya nagkakaroon ng pressure. Basically, compact at efficient ito sa pagpump ng langis dahil sa design ng rotors. Oil pressure regulation. In engines with a full pressure lubricating system, maximum pressure is limited with the pressure relief valve. The relief valve, sometimes called the pressure regulating valve, is located at the outlet of the pump. The relief valve controls maximum pressure by bleeding of oil to the inlet side of the pump. Sa mga makina na may full pressure lubricating system, ang pressure relief valve ang naglilimit ng maximum pressure. Itong valve na minsan tinatawag ding pressure regulating valve ay nasa outlet ng pump. Ang trabaho nito ay kontrolin ang pressure ng bleeding of oil na pabalik sa inlet side ng pump. Makikita sa picture, pag close, calibrated spring holds the piston, keeping the flow block. Pag sobra ang pressure, it pushes the piston open, allowing oil to flow back and regulate the pressure. Factors affecting oil pressure. The first one is leaks. Maraming factors ang nakakaapekto sa oil pressure ng makina. Pero isa sa pinaka-common ay leaks o mga butas kung saan tumatagas ang langis. Hindi naman ito laging dahil sa sira kasi yung mga clearance sa dulo ng lubrication system tulad ng bearings at rocker arms ay talagang design na kasama para gumana ng maayos ang makina. Pero habang tumatagal at nagagamit ang makina, nagkakaroon ng wear and tear. Kaya lumalaki yung clearance na ito at mas maraming langis ang tumatagas. Kaya bumababa ang oil pressure. The second one is oil pump capacity. Ang oil pressure ay apektado rin ng oil pump capacity. Dapat kayang punuan ng oil pump ang mga leaks sa makina. Ang capacity ng pump ay depende sa laki nito, mabilis ng pag-ikot at kondisyon. Pag nakaidil ang makina, mababa ang capacity ng pump. Kung mas malaki ang leaks kaysa sa capacity, bababa ang oil pressure. Pag bumilis ang makina, tataas din ang capacity ng pump. Mas maraming langis ang itutulak nito sa leaks. Kaya tataas ang pressure hanggang sa maximum na regulated pressure. The third one is viscosity of the engine oil. Ang viscosity o lapot ng langis ay malaki ang epekto sa oil pressure. Ang manipis na langis tulad ng mainit na langis ay madaling dumulas sa pump at tumagas sa leaks kaya bumababa ang pressure. Ang makapal na langis tulad ng malamig na langis ay mas mahirap itulak kaya tumataas ang pressure kahit nakaidil lang ang makina. Kailangan pang bumukas ng mas malaki ang oil relief valve para palabasin ang sobrang langis pag malamig ang makina. Kaya mas mataas ang pressure. Kung gagamit ka ng mas makapal na langis, mas mataas ang oil pressure sa mas mababang takbo ng makina hanggang sa maabot ang oil regulated pressure ng relief valve. Oil pump checks. The first one is visual inspection. Pag nag-check ng oil pump, kailangan visually inspection o tingnan ng mabuti ang gears at housing. Hanapin kung may scoring or gasgas. Kung malalim ang gasgas, lalo na sa gears at housing, dapat palitan na ang buong pump. Kasi pag heavily scored, hindi na efficient ang pump sa pagpump ng langis at pwede magdulot ng problema sa makina. The second one is measurement. Kung may light scoring o gasgas sa oil pump, kailangan sukatin ang clearances nito. Kasama dito ang espasyo sa pagitan ng gears at housing. Sa pagitan ng ngipin ng gears at sa pagitan ng side gear at pump cover. Madalas gumagamit ng pillar gauge para sukatin ito at gauging plastic para sa espasyo sa side ng gears at cover. Dapat palitan ang pump pag sobra na ang clearance o malalim ang gasgas. Sa karamihan ng makina, dapat palitan ang oil pump pag may engine work, lalo na kung ang dahilan ng repair ay kulang sa lubrication. Oil passages. Oil from the oil pump first flows through the oil filter, then goes through a drilled hole that intersects with the drilled main oil gallery or longitudinal header. This is a long hole drilled from the front of the block to the back. Ang oil passages ay parang highway ng oil sa loob ng makina. Una galing sa oil pump, dumadaan ng oil sa oil filter para luminis. Then papasok ito sa isang butas na konektado sa main oil gallery, which is a long hole na drilled from harap hanggang likod ng engine block. Dito dumadaloy ang oil para ma-distribute sa iba't ibang parts ng engine, ensuring proper lubrication. Valve train lubrication. The oil gallery may intersect or have drilled passages to the valve lifter bores to lubricate the lifters. Ang valve train lubrication ay crucial para sa smooth operation ng valve train. Ang oil gallery ay pwedeng may connection o drilled passages papunta sa valve lifter bores para malubricate ang lifters. This ensure na ang lifters ay gumagalaw ng maayos at maiwasan ng wear and tear. contributing to the overall efficiency and longevity ng engine. Makikita sa picture yung drain back holes na nagre-return ng oil pabalik sa oil pan after it lubricates the valve drain. Oil pan. The oil pan is where engine oil is used for lubricating the engine. Another name for the oil pan is a sump. A bottle or windage tray is sometimes installed in engines to eliminate the oil churning problem. Ang oil pan, also known as sump, ay yung lalagyan ng engine oil na ginagamit para ilubricate ang makina. Minsan may baffle or windage tray na naka-install sa loob para maiwasan ng oil churning, which happens when the crankshaft splashes around in the oil, causing it to foam up and lose its lubricating properties. This windage tray helps keep the oil calm and ensure consistent oil supply for the engine. Dry sump system. The term sump is used to describe a location where oil is stored or held. In most engines, oil is held in the oil pan and the oil pump draw the oil from the bottom. This type of system is called a wet sump oil system. In a dry sump system, the oil pan is shallow and the oil is pumped into a remote reservoir. Ang dry sump system ay isang alternative na karaniwang wet sump system. Sa wet sump, yung oil ay nasa oil pan at doon kinukuha ng oil pump. Sa dry sump naman, shallow lang ang oil pan at ang oil ay pinapapunta sa isang separate reservoir. This system is often used in high-performance engines kasi mas efficient ito sa pagkontrol ng oil, especially during high-speed cornering or extreme maneuvers, preventing oil starvation. Oil coolers. Oil temperature must be controlled on many high-performance or turbocharged engines. A larger capacity oil fan helps to control oil temperature. Some engines remote-mounted oil coolers. Coolant flows through the oil cooler to help warm the oil when the engine is cold and cool the oil when the engine is hot. Oil temperature should be above 212 degree F to boil off many accumulated moisture. Below 280 degree F to 300 degree F. Sa mga high performance or turbocharged engines, kailangan kontrolin ang oil temperature. Malaking tulong ang larger capacity oil fan, pero minsan kailangan din ng oil coolers. Coolant ang dumadaloy sa oil cooler para ma-warm ang oil pag malamig ang makina at makul naman pag mainit. Ideal ang oil temperature na above 212 degree F or 100 degree Celsius para ma-evaporate ang moisture, pero dapat below 280 degree F to 300 degree F or 138 degree Celsius to 148 degrees Celsius para hindi masira ang oil at ang makina. And this is my reference. That's all my presentation. Thank you.